This is Mr. Boggs, and today I want to introduce series and parallel circuits. So if we look over here at the picture, these are diagrams of series and parallel circuits. In this diagram, this would be an example of a series circuit. And so a series circuit, we only have one branch that electricity feeds through. And so we just have one big circle that the electricity is going to go through. In this diagram, this would be the battery here, and then we go around here. These zigzag lines would be some sort of resistance, and so that could be a light bulb that electricity is flowing through. But we have one, if we follow the path, we have one path for the electricity to flow through. With a parallel circuit, we have our batteries, and we have two or more branches or loops that electricity can flow through. And so if we look from our battery, the electricity could go through this loop and then back. The electricity could go through the second loop and back, or the third loop, or all three at the same time. And so that's a parallel circuit. And so today I want to use the circuit construction kit to kind of demonstrate some things about electricity. So the easiest way to kind of figure out how electricity works is to kind of play around with it. And this kind of offers a safe way to do that. Again, the website is phet.colorado.edu. And so let's go to that website real quick. And here I've already built a couple circuits for us. And so up here we have the battery here, and then so the electricity is going to flow through our amp meter, and that's going to measure the amps, or how much current is flowing through our wires. Then we have a knife switch to kind of turn it on and off, and it's flowing through a light bulb. And so this would be an example of a series circuit. And so let's look at a few things. If we turn this on, we can kind of see how much light we have. We can see how much current we have in our battery. Our battery, if we show the value, is 9 volts. So we have 9 volts of potential energy from the battery. We have 0.9 amps of current. So that current is at 0.9 flowing through our line. And then we have our resistance with our light bulb again. And you can kind of see how bright it is with just one bulb. We can do a couple different things here. If this is a series circuit, we can add another light bulb. So one of the things that we can kind of see whenever we have these attached, that's called a closed circuit. And so with a closed circuit in a series, electricity is going to flow. But you see, once we break that line, if we cut that wire, what happens to the flow of electricity? It's going to stop in a series circuit. So we can add another light bulb here, and now we have 2 light bulbs. And so you should have noticed that the light from both of these light bulbs, it got dimmer, and you should see at the amp meter that it went from 0.9 to 0.45, and so the current reduced in a series, and that's because both of these light bulbs are using up some of that electricity as it flows through. So we can get out a voltmeter also and kind of play around with the volts, so we can see that our current went down. What happens to our volts? So if we go on either side of our light bulbs, you can see that we still have 9 volts. But if we move these to either side of one of the light bulbs, what do we have? We have 4.5 volts now. And so each one of these light bulbs in a series is going to reduce the amount of voltage through it, and so it's using some of that electricity for each bulb, and they're kind of sharing the electricity in a series circuit. And again, if we take that out, you can see it goes back up to 9, and so we can let's put that back in real quick. Back to 0.45. So let's move our voltmeter out of the way. And so the things you should learn about a series circuit is that if you cut the line at any place, then that electricity is no longer going to flow. And also that the things that provide resistance. The light bulbs, they're going to use up, they're going to have the same amount of electricity going through both of those. So they have the same amount of current. The volts can vary depending on how many light bulbs you have in there. So the more light bulbs you go, the more that current and the more the voltage is going to go down, because it's going to share it between all those bulbs. So let's go down. Let's look at the rays of the light bulb here, and then let's turn on the parallel circuit. And so we can see with the parallel circuit, the light bulbs are a lot brighter. And so the first time I saw this, I didn't really know what was going on. It was kind of confusing to me. So why are 2 light bulbs in a parallel circuit brighter than 2 light bulbs in a series circuit? And so we can kind of see how this is set up. So let's look at that. You should see that whenever we turned it on, how much current do we have here? We have 1.8 amps of current going through here. And so again, we have 2 branches that electricity can flow through. So what does that mean? That means if we separate one of them, what happens to the other one? It keeps going. And so now electricity can either flow through this one, or if we disconnect that, now it can flow through just the back one. And you should have saw that the amps went down to 0.9 whenever we disconnected that. And so if we add the other one, if we connect it again, what happens to the current? It goes up. And so whenever we have 2 light bulbs or more light bulbs, you're going to be drawing more current out with a parallel circuit. And so the battery is not going to last as long in a parallel circuit, because we're actually using up more of that electricity. You can see that the flow of electricity is a lot faster than up here in the series circuit. And so we can add switches to here. So if we have a switch between the battery and all those branches, we can control all the light switches in that parallel circuit. And so if we think about what's in your house, what's wiring your house, it's going to be parallel circuits. Otherwise, if we used a series circuit, then you would have to have all of the lights. If your lights were wired in a series, you'd have to have every light on in your house to just get them to work. Once you flipped one of them off, that would turn off all the lights in your house. And so we set up your house is probably wired with, is going to be wired with parallel circuits. And we can also add a switch if we just wanted to control one light bulb. And so let's disconnect this and add a switch in here. We can put it on just one of those branches and control one light. And so if we turn it on, we can turn it on and off. And so that's how it works in your house. Each individual room has its own switch in which you can turn on the light. So just because you could have switches that go to plug-ins and things like that also. So you may have something like that in your house as well. Or you can use this switch and control both of them. And we could put another switch on this one and have those two controlled also. So what you should learn about parallel switches or parallel circuits is that if you disconnect one, it doesn't affect the other one, but it does affect how much current it's drawing from the battery or from that power source. And so just to kind of compare those two, I remember when we used to have the old Christmas lights that were wired in a series, and it was really annoying because whenever you one bulb burn out, the whole strand would go out and you'd have to figure out which one was burnt out. Nowadays they wire them in a parallel circuit, and that way if one bulb burns out, the whole strand doesn't just go out on your tree, and so it makes it a lot better. So that is one other thing before we wrap this up. We can look at the voltage. And so one of the things that we notice, let's look at right here. So if we have just look at the voltage for one of the lights, we notice that it is 9 volts. And so if we looked at it for the other light, we can see that it's also 9 volts. So we can kind of move this around and kind of look at some different things. So each one is drawing 9 volts, but if you add those together, we get 18 volts, and so that's where we get our 1.8 amps. And so if we turn one of those off, just one of those bulbs is going to draw 9 amps, or 0.9 amps, and so it doubles if you close the circuit there. And so hopefully this was helpful. Hopefully you get on here and mess around with electricity a little bit, and it kind of gives you an understanding of parallel. You can build parallel and series circuits and kind of mess around with that and figure some things out. So hopefully that was helpful, and we'll see you next time.